So, getting into our last chunk of notes for the chapter. Starts on page 14. And essentially, we're introducing our final two postulates / theorems that help us prove that triangles are congruent. So far, we've come across side angle side and side 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 we introduced yesterday. Now, I don't have the full side 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 filled in on my postulate sheet currently, but I do have my pictures marked up because the pictures are one of the most useful things for a lot of people when it comes to this chapter, when it comes to showing that triangles are congruent. Today, we're adding angle side angle and angle angle side. Now, our goal here is still to show that triangles are congruent. And if we used the definition of what it means for shapes to be congruent, we'd still have to show all three sides and all three angles and have 6 congruencies in our proof. These postulates, these theorems, allow us shortcuts. So, you will have 4 shortcuts for showing that triangles are congruent. SAS, SSS, ASA, and AAS. The way that angle side angle works states that if you have 2 angles and the included side, in other words, and the between side, marked as congruent in a triangle, as compared to another triangle, you could say those triangles are congruent. So here's how that works. It's going to be like angle A is congruent to angle D. As well as you also know that angle B is congruent to angle E. I'm going to do the double angle marks for that one. And you know that the side between them, AB, is congruent to DE. That is what angle side angle looks like. And I'm going to mark those markings on my picture, on my postulate sheet while I'm here. I can get the words on it later. But I'm going to put that for angle side angle. And if you have that, then you could say the triangles are congruent. And in this case, it's triangle ABC and triangle DEF. Because angle A corresponds with angle D, B matches up with E, and then C matches up with F. That is what angle side angle looks like. Angle angle side is very similar. It also has 2 pairs of angles congruent, so it starts off the same way. Angle A is congruent to angle D, as well as angle B being congruent to angle E. The difference between angle side angle and angle angle side is where is the side located as compared to the angle. For angle side angle, they put the S between the 2 A's for a reason. The side is between the angles. For angle angle side, the side is not between the 2 angles. So in these triangles, it could be either of these sides. I'm going to choose BC. To be congruent to EF. And that is another shortcut for showing that triangles are congruent without having to show all 4 sides and all 3 sides and all 3 angles. Two angles, side not between. And I mark it on my postulate sheet on the triangles as well. I'll get the word piece of it later. The picture is probably the most important piece. Other than adding a couple of more ways to show that triangles are congruent, the process of what we do today is the exact same as the process we did yesterday, is the exact same as the process we did on Friday. We're doing some proofs. Proofs always start off in 2 columns. At least the ones that we do. There's other types of proofs. And I start with my given. After I've got my given down, I can look through my 5 things that I look for in a proof, which has been shortened down to essentially 3 things. Either way, what do you start with first?
Words.
I have the word bisects. Which sheet has all my words on it? Orange, or at least it's got most of the words. It doesn't have all the words, but it's most of the words. What kind of bisect am I working with? Is it a segment bisector or an angle bisector? Look at this thing. Is that an angle or a segment?
Segment.
That's a segment. That's the type of bisector it is always the second thing, the thing that follows the word bisects. So we're going to use the definition of segment bisect. Look at the thing that's getting bisected. AD. That's the thing that's going to become 2 congruent parts. The first thing that comes before bisect is the knife. Do you see where BE cuts AD into 2 congruent parts? What are they called? What are the 2 parts called? Where BE cuts AD into 2 parts. AC and CD. What have I not done in my proof so far that I probably should? Mark the congruence on the picture. I have 2 congruents in my proof right now, but I have nothing marked as congruent in my picture. Angle A is congruent to angle D. We were given that. I marked those angles. Segment AC is congruent to segment CD. I marked those sides. And I look for other things. I took care of words. I do have symbols. I have congruent symbols. Do I do anything with congruent symbols? No, I'm just happy they're there because I want them. Do I typically do substitution or transitive now? Do I typically do algebra? Do I typically look at a picture? What types of things do I look for in a picture right now? It's really only 2 main things we look for in a picture at this point. Do the triangles share a side or share an angle? Do they overlap on a side or an angle? No. They overlap at a singular point. Point C. A point is not an angle or a side. No. So, that's our reflexive property if it had come into play. It doesn't. The other types of things that come from pictures are these 4 things. Which one actually shows up in these proofs? Vertical angle theorem. Do I have vertical angles? Yes. I see the X right here. That angle and that angle are across from one another on it. They're both in the triangles, so they are congruent. Angle. What's the name of this angle? Need to use a three-letter name. ACB. Angles are either one letter or three letters. You cannot use one letter if there's multiple angle C's. So ACB is congruent to angle ECD. And that's vertical angle theorem. Mark the congruent here, mark it in the picture. How many congruents do I have? I have 3. How many do I want? 3. No, reflexive is them sharing something. We have 3 congruents. Okay. Does the setup look like this? 2 sides and an angle between? There's only one side marked as congruent. It's not that one. This one's 3 sides marked as congruent. No, there's only one side marked as congruent. Is it this setup? Yes, 2 angles and the side between them. Is the other triangle the same? Yep. 2 angles and the side between? Which one's that one called again? ASA, angle side angle. Side, 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 angle, side, and angle, side. All tell me triangles are congruent. So I can go to my proof. Okay. We're not going to do all of the proofs in this section, but we are going to do a few more. We are going to take a look at B, the top of the next page. Y'all know how to start it. 2 columns, labeled S and R, and you're given. What do you see? Words. See the word midpoint. Where am I finding the word midpoint? Orange sheet. One of the things when you find that word midpoint, make sure you're looking at midpoint. Far too many people are seeing the word midpoint and writing bisect. Are midpoint and bisect the same word? No, they're similar, but they are not the same thing. You're using definition of midpoint, not definition of bisect. Okay, we are told B is the midpoint of DC, which means B should make that segment 2 congruent segments. What are the names of the 2 segments? They're DB and BC. Can I call them BD and CD? Yes. Mark it in the proof, mark it on the picture. Do not mark it on the picture until you put it in the proof. That's one of the things that people tend to make a mistake on as well. the next thing you see? I agree there are vertical angles. Yes, you can use the vertical angle theorem next. But that doesn't tend to be what we go for next. It's not wrong to put it next. Typically next we see the symbol. Some of y'all mentioned there's a parallel symbol. I'm going to go there next. If you did vertical angle theorem next, you wouldn't be wrong. I'm going to work with the parallels first. When I work with parallels, I make them longer. Easier to look at, easier to compare to which postulate sheet? The yellow one. Now, to do this, I need two parallel lines. I also need a transversal. The transversal needs to be whichever segment, whichever sides will give me an angle that shows up in both triangles. If I were to use this one, do these two cross and get an angle in the triangle? Yeah. Yep, they get that one. Do these two cross and get an angle in the other triangle? Yep, that works as a transversal. In all actuality, the other one would have worked too. This picture is one of few that would work with either of them. I'm going to continue to use that one as my transversal. So I'm looking at this angle and this angle, which if I match up my parallels, it's kind of in the spot of 3 and 6. What kind of angle pairing are they? Alternate interior angles. AIA, don't forget the other part, theorem. By the AIA theorem, they are congruent. Can I call that angle A?
No.
Is there only one angle A? Yep. You say angle A, I know which one you're talking about. Yeah. When I wrote in the orange lines, it looks like there's more angle A's now, but were the orange lines ever actually there? No. Angle A is congruent to angle E. Congruent, congruent. Trevor mentioned he saw vertical angles earlier. Can we use that? Yup. That angle and that angle are vertical angles. What is the name of this angle? ABD is congruent to CBE. Don't forget the angle symbol. I mark the congruence in the picture once I have it in the proof. That was vertical angle theorem. How many congruents do I have? 3. How many do I need? 3. So I look at one triangle and I ask myself, does it look like this setup? 2 sides and the angle between? Do I have 2 sides marked as congruent? In a single triangle? No. So, not that. Do I have 3 sides marked as congruent? Do I have 2 angles in the side between them? No. I think I said that wrong. Do I have 2 angles in the side between them is what I meant to say. I got 2 angles, but is this side between them? No. Do I have 2 angles in the side not between them? Yes. Which one is this? Angle, angle, side. So be careful with those. The reason these triangles are congruent is because of angle, angle, side, not angle, side, angle. They're similar, they're not the same. Triangle ABD is congruent to triangle EBC. I want to do one last one, and it's D. skipping over C and skipping over E. D is on the back page. Lock this on me. Statements, reasons, given. Angle S is congruent to angle U. RS is congruent to VU. Angle S, angle U. RS, VU. The reason I like to do this one after the last one is because this one looks very similar to the last one. Like, really, really close. It's that bow tie shape almost again showing up. One of the things that people tend to try to do on this one is they tend to try to do alternate interior angles. What is necessary to do alternate interior angles or corresponding or AEA or CIA? If parallel, if parallel, if parallel, if parallel. Do I have parallel? No. Do not do anything with these four angle pairs unless you see parallel. You have to do something else. I don't have words. I don't have symbols I can use. I've got a picture. What can we get from the picture? Vertical angles. Do you see the X showing up with the sides again?
Yeah.
Angle, it's RTS and UTV. Do you notice I already have 3 congruent symbols?
Yeah.
I notice 2 of them are angles, 1 of them is a side. The question is, if it's 2 angles and 1 side, is it angle, side, angle, or angle, angle, side? Here are my 2 angles. The question is, essentially, is the side between them? No. It's angle, angle, side. This is a whole 3-step proof. Did I mention that these proofs are the shortest?
Yeah.
Yeah. Because they can be this short. When's the last time we had a 3-step proof? Never. We had more 8-step proofs than 3-step proofs. So, I wanted to show that one because of the similarities but also differences that it has with the one that we did. Today we did 5-6. It's the 11th. Our homework's due on Thursday. In fact, Thursday is the day of the test, which means it's the last day to turn in any homework for the chapter. So, if you have not turned in homework assignments, we better be getting on that.